This is PGSMaths, I'm PH, and today I'm going to be talking to you about protractors. Right, first off, we'll just look at a half-size protractor. This tool is used for measuring angles from a point, and each of these small marks around the outside represents 1 degree. In a half-size protractor, this goes up to 180. Around the inside, we'll see exactly the same numbers, but going in an anti-clockwise direction, but still goes to 180. More commonly, we would use a full-size protractor. This again will start at 0, and around the outside each small mark represents a 1 degree turn. Just like a half-size protractor, this will continue until 180 degrees is reached. But the more useful full protractor will continue round until a full rotation has been made at 360 degrees. If we wanted to measure an angle anti-clockwise, we would continue using the inside numbers. These again continue to 360 degrees starting from 0. If we look now at how angles are created, with a single line there is no angle, but as we add a second line we create these acute and sharp angles. These numbers go up until 90 degrees is hit. At 90 degrees we create this nice right angle. Beyond this we have what's called obtuse angles. These go between 90 to 180 degrees, where we have created a straight line. Beyond that is called a reflex angle. This is bigger than a straight line, but it's not quite a complete turn around the point. So between 180 degrees and 360 degrees is called a reflex angle. So how do we use a protractor to measure an angle? Well, an angle is created between two lines. It's the distance which it has been rotated and is represented by this little arc. Now if we're going to measure this clockwise, we need to see the distance from this point that the lines have been rotated. In the middle of your protractor you should notice a small cross. So you need to make sure that that cross is lined exactly where the two lines meet. Once that's in place, that's the hard work. And the closer you get to the middle of those two lines, the more accurate it will become. Now the thing that we need to do is to make sure that the beginning of our angle is at 0. So our first line must be in line with 0 while keeping the cross in the middle of the angle. Now it's important to get this as close to the line as possible. This way we ensure the most accurate measurement that we can possibly find. So we've kept the cross in the middle of the angle, and we've now lined up 0 with one of our lines. Now while it's not important to find out which line this is, I always suggest the left one. Then all we do is measure from 0 going up until we hit the second line. So this time we use the outside numbers, so going from 0 all the way up. We'll notice that our line hits exactly at 60, and this can be written as 60 degrees. So what about this angle? Well, this one looks much bigger. So this one we know is probably going to be an obtuse angle. But if we measure this arc, we can prove that it should lie between 90 and 180 degrees. Round the outside, we have this reflex angle as well. So we're going to start off by making sure that we measure the obtuse part of our angle. With every angle we make sure that that cross at the centre of our protractor is lined up at the point where the two lines meet. Again, accuracy is important. We still need to make sure that 0 is lined up, and this time though I'm going to go for the right hand line. As I said, it doesn't make any difference which one you use, just making sure that you go the right direction. Now if we tried going from the outside, we would be measuring the reflex angle. So this time we're going to have to measure using the inside numbers to make sure that we're following the angle we want. So going around the inside, we continue in exactly the same way that we did when we measured clockwise. Now this time it's going to have to be a little bit of an approximation, but using an extended line we can see that it crosses somewhere between 130 and 140 degrees. If we can read the outside scale, we would see that that landed at exactly 135. Now the outside scale says a number in the region of 225, so we know it has to be the smaller number, 135. because we know this is an obtuse angle. So what do we do if we want the other angle, this reflex angle, which comes around the outside? Now we've already measured the angle on the inside, and what we should notice is that we can still measure this in exactly the same way, by lining up our protractor, putting the cross where the two lines meet. By adding up both of the angles, by putting them next to each other, you should be able to see that this creates a full circle. All the angles around that point then must add up to 360 degrees. So without measuring it, we know that whatever the other angle is must add up to 360. So if we take this little one away, the 135 that we've already measured, whatever's left over should be our missing reflex angle. And this little trick is very useful if you only have a half-size protractor. So we know we can't take away 135, but by borrowing one from the 6, we can do this subtraction very easily and find out we are left with 225. Now that number seems very familiar. That's what we thought that the angle was before. So obviously that's got some kind of relationship, but let's just prove it, shall we? Let's get the 0, and making sure that we keep the cross in the middle, that we rotate the protractor and get 0 lined up with one of our lines. Now that it's in line, we can measure the number of degrees that this is rotated by, starting at 0, following the outside this time because we can measure clockwise, and we'll see that it crosses on the 225 mark. Now, I lost a little bit of accuracy there, didn't quite make sure it was lined up, but we know it should be 225, so check it again. There it is. Okay, a little bit of a recap quiz to see what we've learnt from now. Just guessing, looking at that angle, how many degrees do you think it would be? Is it going to be A, 30 degrees? Well, what does 30 degrees look like? What type of angle is it? Is it B, 90 degrees? Or is it C, 120? Now, we can measure this, so just to give you a little hint, let's line up our protractor. Is it on 0 yet? Don't think so, but there's 90. Have I got my 0 lined up? Maybe it's not 90. Let's get the 0 lined up with one of our lines. Now we should be able to clearly see now, even before it's lined up, which number it's closest to. Going clockwise around the outside, that looks pretty close to the number 30 to me. So how do we know that the correct answer was indeed 30 degrees? Well, it's an acute angle, it's very sharp. 90 degrees, that's a right angle. That doesn't look like a right angle. And 120, well, that's obtuse, that would make a much wider angle. So looking at a wider angle, let's see if we can work out which one this would be. We have an obtuse angle this time. So would it be A, 45 degrees, B, 140 degrees, or C, 220 degrees? And line the protractor up, putting the cross between where the two lines meet, and 0 is lined up with our left hand line. Does that give you any hints? Let's have a look at our first answer, 45 degrees. Well, that's less than 90 degrees, so we know that would be acute. It's definitely not there. Far too small a number. But now we've got 140 degrees. So we follow around the outside. That does indeed hit at 140. But it also hits 220. So which number do we use? Well, we're going clockwise, starting at 0, so we have to follow the outside numbers. It gets bigger from 0, which means we do want 140. You said 140 degrees, well done. 220 degrees, even though the line is on that number, would be going round the other direction, and that would make it a reflex angle, so it's not 220. Now we're going to look at what happens when we create multiple angles next to each other. We have an angle created between this line and the next one, and then another angle created with a third line. All of these lines meet at one point, So it's very easy to line up our protractor. We put the cross where the two lines meet that are important. For this case, we're looking at the blue angle. So we pick one of the lines in the angle that we're trying to measure and line up 0 along that line. That's the beginning of our angle. We need to check and see where the second line hits the protractor. In this case, it's 60 degrees exactly. Do we just measure the next number now? Do we just go along and say, right, the next angle is 135 degrees? No, because that middle line is the important one this time. So we line up 0 with the middle line, so now we have the start of our pink angle. We can measure clockwise round until we hit the next line, and this case reads off approximately at 73 degrees. 73 seems like a much more realistic number. It's an acute angle, it's very sharp, so therefore we can believe that that is the angle. Now on this side we are left with a reflex angle. Now what did we remember about the angles around a point? Well, they must add up to 360 degrees. Just like we did in our earlier example, we can take away these two angles, and whatever's left must be our reflex angle. 60 add 73 is 133, so if we take that away from 360, we are left with what we think our angle should be, and in this case 227 degrees. It's always useful to check before you measure an angle what you think the angle should be. So we line the protractor up, put the cross where the lines meet. We make sure that 0 is on one of our lines. So I'll just move it to the next one along. Again, accuracy is important. Measure from 0 around, and we see that it is at about 227 degrees. So how do you use a protractor to draw a specified angle? In this example, we're going to look at how to draw an angle of 75 degrees. And to do that, we need our starting point, a line which represents 0 degrees. So this line here, we pick one of our sides to be where our angle is going to be. So I'm going to use the right hand side here, and our line is going to come off somewhere from there. Undoing what we would do before, we can line up our cross where we want our angle to actually be. So put the cross on the end of this line. And this line is going to represent the beginning, so we need to make sure that 0 is lined up with that line. Now we know where our angle is going to begin, and we know where 0 is. All we do is measure round until we get to where 75 is. So that's somewhere between 70 and 80, halfway, and we can draw just a little dash with a pencil to find out where 75 degrees actually lies. Take the protractor away, and now to create our angle we go from the point to where we measure 75 degrees is, and that's our 75 degree angle. Always a good idea to double check it, however, so just put your protractor back on, make sure 0 is lined up with your first line, measure it again. You should see that the line crosses straight through the angle that you wanted, which in this case is 75 degrees. So what we've measured there, just to prove it, was 75. You might want to pause the video here and try this one yourself. I want to draw an angle of 115 degrees next to the angle we had before. Here we go. Well, we've already got the point where our angle is going to be drawn from. So we line up our protractor at that point, but this time we're going to use the new line. If you try drawing a second angle from the original line, you're just going to go over the top of our original angle. So once we've got a protractor lined up with the new line, you can just measure from 0 up to 115. This is going to go past a right angle at 90, and that'll be somewhere between 110 and 120. Draw a little dash with your pencil, pull the protractor away, and then we can draw a line from the middle of where our angles are to that little dash. What we've done now is added on another 115 degrees from our previous angle. We've used our new line to make sure that we had a new starting point of 0. And whenever you draw any angle, remember, just put your protractor back on and double check it. Now if we look at this one at the moment, it's quite close to 115, but my protractor's not exactly in the right place. Notice as I move the protractor just slightly, I move like 3 or 4 degrees off. It shouldn't do that, so what it tells me is I haven't got the cross in quite the right place. So make sure the cross is exactly in the middle where your 2 lines are, and 0 is on your 1 line, and that gives us 115 degrees. Our final challenge today is to look at how to draw an angle of 280 degrees. Now if you're using a 360 degree protractor, this is really easy because it uses the exact same method as drawing an acute or an obtuse angle. You draw a line, you line up the cross with the end of the line, and then measure round from 0 until you find 280 degrees. Draw a little tiny dash, pull the protractor away, and line up the end of your line with that dash to create 280 degrees. Make sure you use a ruler for this, otherwise you're not going to get the exact angle. But this lovely reflex angle here we've just shown is 280 degrees. But what happens if we don't have a full protractor? What happens if we've only got a half protractor? That only goes up to 180. There's 2 ways of actually using this protractor then to draw our reflex angle of 280. What we're going to look at is the easier of the 2 methods. Now, we know that all the angles around a single point must add up to 360 degrees. I apologise, I think the numbers disappear off the top of the screen here. But we know they add up to 360. If we take away the 280 degrees that we want, we can see that there are only 80 degrees left over. Now 80 degrees we can actually draw using a half-sized protractor. And this simple method will allow you to draw any angle which is bigger than your 180. So now, using exactly the same method we did before, you line up the cross of your protractor at the end of your line. Again, accurate as possible. And this time we have to make sure that the 0 is along the line. Looks a little bit different from the 360 degree protractor, but it's exactly the same skills. Starting at 0, we can measure round until we hit 80. Draw a small little dash and pull the protractor away. Using a ruler, join up the end of your line to where the dash is. And what we've created there is an 80 degree line. Let's just double check that. Line it up. Yep, nice, 180 degrees. Now if we measure this with a 360 degree protractor, we can see again, if we've got to line up the 0 at the end of our line, and we can see using the inside numbers we get 80 degrees, but around the outside, clockwise, we do have our 280 degrees. Now it's time for a final challenge. Can you work out what shape this makes? You're going to draw 5 lines, each of them 5 centimeters long, and you're going to turn 36 degrees clockwise each time. Slightly different from the tutorials though, you're not drawing them all from the same point. You need to draw the new line from the end of the line that you previously drew. Post your answers in the comment section below with any requests for topics or problems that you would like to see in future videos. Do remember to follow us on Twitter at PGSMaths, join our Facebook page on facebook.com/PGSMaths, and do subscribe to our YouTube channel to keep up to date with all future maths related videos.